Okay, pre-cal students, in this video we will be looking at standard position of an angle. We will also be looking at coterminal angles, and we will also be looking during this video today at quadrants of the coordinate plane. All right, quadrants of the coordinate plane. Please go ahead and write this heading down. The first heading that I'd like you to write down is standard position of an angle. I would also like you students to go ahead and write the date down so that you have organized notes. So go ahead and copy today's date down. And I'm going to go pretty fast like usual, so if you have to pause the video, please feel free to do that. Okay, standard position of an angle. It's very important that you understand this because we're going to use this a lot in trigonometry. Okay, so let's continue on. It would probably be wise if we paused here, and we really need to make sure that everyone knows what the initial and terminal side of an angle is. So here we go. Please take some really good notes. Go ahead and draw an angle that looks something like this, please, and we'll draw an angle there. Okay, now usually in geometry you would see a little mark right here indicating this is the angle that we're referring to. In trigonometry, quite often you're going to see direction, and by the way, we're going to learn here in a little bit today during this video that direction in an angle constitutes positive or negative angles, but we'll get into that a little later. Let me go ahead and do this. Please copy this in your notes. I want you to start here, and let me change color so you can see it very well. I want you to start here and draw a curved line, but put an arrow on the end of it like that. Now, what that means is we're moving in this direction. So if we're moving in this direction, that means we started here and we rotated to here. So whenever you see that arrow like that, then you know the starting ray or the starting side right here is going to be called your initial side. Please write that down. You need to understand these terms. We're going to use these words a lot. Now, notice we started here and we rotated this direction and we ended right here. So we ended at this side here. So that ray or that side of the angle right there is called your terminal side. Your terminal side. Does that make sense? So now you know what the initial side and the terminal side of an angle is. And by the way, it would be completely acceptable in trigonometry to have an angle that would rotate down like this. It would also be acceptable to see an angle like this, starting here and rotating like that. Okay, that would also be normal. And we'll get into that later. But what you need to know right now is what the terminal side and the initial side of an angle are. You need to know what those two terms are. So with that in mind, let's go ahead and continue on now. Let's start off with the definition, and then I'll give you some examples of what we mean by standard position of an angle. Go ahead and copy this definition down. I'm going to move on, so you'll probably have to pause the video. Let me get a drink real quick here. An angle is considered to be in standard position, now listen carefully, when its vertex is at the origin of the coordinate plane and its initial side lies on the positive x-axis. Okay, so that is what we mean when we say an angle that is in standard position. Now, having said that, having given that definition, let's look at some visual examples. So probably in your notes, you're going to want to draw, I don't know, 2, 3, 4 of these coordinate planes like this, so we can put some different angles on each one. Okay? So here's an example of an angle that is in standard position. My initial side is right here, and we'll say my terminal side, even though I'm not drawing it very well, let's try it like this. There we go. And we'll put an arrow here showing the angle is rotating this way. Okay? Now that angle is in standard position. Let me show you why. First of all, is the vertex of the angle at the origin right here, or in other words, is it at 0, 0 on the coordinate plane? Yes, it is. And this is your initial side. Is your initial side lying on the positive x-axis? Well, yes, this is your x-axis, and anything from here over, all of this here is considered your positive part of your x-axis. So this angle here would be in standard position. All right, let's go ahead and look at another example. You can go ahead and draw another coordinate plane. This would be an example of an angle in standard position. First of all, notice the vertex of the angle is at the origin. And then here's my initial side. And now we're going to rotate this way, like this. We're going to start here and put this arrow here in your notes. We're going to rotate like this. Okay? Now, that angle is in standard position because here's your initial side and it's lying on the positive x-axis. Here's your vertex. It's lying right at the origin. So this angle is in standard position. Now, I could make one change and this angle would no longer be in standard position. If I started here and went this direction like this. There. That angle is not in standard position because here's your starting side right here, and is that starting side or your initial side, whatever you want to call it, is this initial side lying on the positive x-axis? No, it is not. The terminal side is lying on the positive x-axis, but the initial side is not. So understand, we have an angle in standard position when the initial side lies on the positive x-axis and the vertex of the angle lies at the origin. Now, one more thing I need to show you. Please make note of this in your notes. Are you ready, students? Please make note of this. Let's go ahead and put our arrow here like it should be, and let's call this 150 degrees. Let's say from here to here, this angle right here that I'm highlighting in green, we're going to say that's 150 degrees. Well, in trigonometry, we would call this negative 150 degrees because we rotated down and around this direction. We rotated clockwise, and clockwise means you have a negative angle. Please don't forget that. Okay, so if we start here and we rotate clockwise, the angle will be negative. I would like to show you something else. Would you please go ahead and get another coordinate plane drawn? We can have angles that are larger than 360, negative or positive, that are in standard position. Okay, go ahead and write this angle here. All right, and let's go ahead and put the other ray of the angle right here, and then let's go ahead and make a note that it's rotating this way. Okay, now in fact, let's go ahead and erase that arrow. Let's do it like this. Let's say we started here. Now watch this, and let's say we drew the arrow like this, and this is a very normal trigonometric symbol. Okay, well, that angle would be, well, we rotated around 360, and let's just pretend this little angle right here is 60 degrees. This little green angle right here is 60. So that means we rotated around 360 degrees plus 60 more. So we would call this angle 420 degrees. That's very standard in trigonometry. And is this angle in standard position? Well, you tell me. Is the vertex of the angle at the origin? Yes, it is. Is the initial side where you're starting at, does it lie on the positive x-axis? Yes, it does. So this is an angle that is in standard position that is bigger than 360 degrees. Okay, now let's make one change, and you can go ahead and draw another coordinate plane in your notes if you want to, however you want to do this. Let's say we started here, and let's say we went around once, twice, and then we ended right here. Now I know you can get a little bit of a headache trying to see how many times the circle goes around here, but let's take our time and look at this. First of all, notice that I started the angle right here, so this is my initial side, and notice the vertex is at the origin, so I do have an angle that's written in standard position. Okay, so by now, you should really understand how to write an angle in standard position. Make sure the initial side is on the positive x-axis, and make sure the vertex of the angle is at the origin. But now, what if I asked you for the measure of this angle? We already know this little angle right here, this little green or red angle here, we already said that's 60 degrees. So let's see what we have here, okay? We started here, and we went around once. That's 360 degrees. And then we went around once, then we went around again, that's another 360 degrees, so we went around once, and then we went around again, and then look what we did. We went almost all the way around again, and we stopped here. Well, if this little angle here is 60, that means we went around 300 degrees. Okay? Let's take a look at this again. I want you to really get this, okay? So please watch this. Okay, we went around once, that's 360. Then we went around again, that's another 360. And then we went 90, 90, 90, that's 270, plus 30 more, because we know this is 60 right here, this little angle here. So we went around 360, 360, and 300. So this total angle would be 1020. Now hold it, 1020 degrees, and what else? It would be negative. Why is it negative, Mr. Earhart? Because we went clockwise. We started here and we went down. We went clockwise, okay? When you go clockwise on your angles, they will be negative. When you go counterclockwise on your angles, they will be positive. You might want to make a note of that somewhere in your notes, or at least memorize it this way, however you want to do it. Okay, so let's review. You should really understand now what this definition means. An angle is in standard position when its vertex is at the origin and its initial side, that means the side you're starting with on your angle, is on the positive x-axis. Okay? All right, let's continue on and look at something else. Now, I would like you to sketch these angles in standard position. I'm going to go very quickly, so please take some really good notes quickly. Now, in these situations, I'm going to give you a choice. You can convert these over to degrees very quickly and use degrees. I have no problem with that. Or you can leave them radians, and I will do both of them very quickly. Remember, when you come up here, this is 90 degrees, or pi over 2. This is 180 degrees, or we call that pi. This is 270 degrees, or we call that 3 pi over 2, or 1.5 pi. And this over here, when you rotate all the way around, is 360 degrees. We also call that 2 pi. Okay, so let's go ahead and sketch the given angle in standard position, pi over 3. Now, if you were to convert that into degrees, remember how to do that. We would multiply it by 180 over pi. We learned this before. Your pi's would cancel, 3 would go into 180, 60. So pi over 3 is 60 degrees. You could also realize that because you're starting from here and you're going almost to 1/2, so 1/3 pi would be just about right here. And we're just approximating it, so there we go. So we'll go ahead and we'll put our starting side here. We're writing the angle in standard position, and we're going to rotate up pi over 3, or 60 degrees, however you want to look at it, okay? So there we go. We wrote the angle in standard position, all right? And if I'm going too fast, just pause the video and watch this part again. Let's take a look at another example. Let's go ahead and sketch negative 2 pi over 5 in standard position. Well, first of all, let's convert it to degrees, if that helps you. So we're going to go ahead and put 180 over pi. Your pi's would cancel. 5 would go into 180 36 times, and 2 times 36 would be 72, so we have negative 72 degrees, which does make sense because 2/5 is less than 1/2, and don't forget, if you were to rotate all the way up to 90 degrees, that's 1/2 pi, or pi over 2, and we're at 2 pi over 5, or 2/5 pi. That's not quite to 1/2, so we're at 72 degrees, and I would say 72 degrees is approximately right here. So I'm going to go ahead and draw. Well, you know what though? Hold on. Mr. Harrop made a mistake. Don't forget, and that's my fault. We're looking at a negative angle. So let's go ahead and draw our initial side first. And then remember, if it's a negative angle, you're going to move clockwise, not counterclockwise. If it was a positive 72, then we would rotate up to about right here, and then go ahead and draw our angle and put 72 degrees here, or 2 pi over 5. But it's a negative 72 degrees, and so we're going to rotate down this way to about right there. I'm just estimating, of course. And we're going to go ahead and draw our other ray of our angle here. There we go. Pretty badly drawn, but that's okay. And we're going to call this negative 72 degrees, or you can call it negative 2 pi over 5. There we go. All right, let's take a look at another one here. All right, let's take a look at 8 pi over 3. Let's go ahead and see if we can't get a little space, move it over here a little bit, and here we go. Let's convert it to degrees. That might help us a little bit. So 180 over pi, your pi's would cancel. 3 would go into 180 60 times, and 8 times 60 is 480 degrees. Now that really makes sense to me, because think about it. 8/3 pi, is that not really 2 2/3 pi, students? Sure it is. Think about it. 8/3 pi, or 8 pi over 3, is the same thing as 2 2/3 pi. Well, we know one rotation is 2 pi, and then we go 2/3 more, which would be 60 degrees, or 120 degrees, okay? So we do keep going all the way to here. So look at that again. If I was rotating 2 2/3 pi, I would rotate 2 pi, and then a half a pi, and then all the way over here to about 2/3. This would be 1 pi right here. Now, if you don't like what I just did there, that's okay. You can at least use the degrees. I just want you to try to get used to using radians. So I rotate 2 2/3 pi, or you can rotate 480 degrees. Now, it is a positive 480, so we're going to start our terminal side right here, and we're going to rotate 360 degrees, and then 90 more would be 450, and then 30 more, here we go, 30 more would be 480 degrees. Okay, and you can count that up if you want to. Watch it again. 360 plus 90 more is 450, plus 30 more would be 480. So there, we did it. We drew 480 degrees. We can write it right here. We drew 480 degrees in standard form, or we can also say we drew 8 pi over 3 in standard position. Okay, 360 plus 120 more. Okay, let's take a look at a couple more, and we'll go a little faster here, and then we'll be finished. Okay, let's take a look at 125 degrees. Really a pretty simple problem. 125 degrees is positive, so we're going to start here at our initial side. If we rotate it all the way to here, that would be 180. It's a little too far. If we went right in the middle, that's 135, right? Because right in the middle here would be 45, and from here to here is 90, and 90 plus 45 is 135, so that would be a little too far. So I guess I'm going to draw it just about here. I'm estimating, and on a test or a quiz, that would totally be sufficient. Okay, so there we go. And so we're going to go ahead and put our initial side here, rotating to here, and there we go. We just drew 125 degrees in standard position. Okay, let's go ahead and take a look now at negative 550, and we'll move on to something else. Okay, let's draw 550 degrees, negative 550 in standard position. So here is my initial side. All right, now be careful here. I'm going to rotate down because it's a negative 550, so there's 360. Let's go 90 more. That's 450. Let's go 90 more. That's 540, and we want 550, so we'll go just a little more for that 10 degrees, and it's just an estimation. And we're going to say, I guess I should change the colors back to blue. We're going to say, here's our terminal side right here. All right. So do you see what we did? Negative 550. So we went down clockwise because it's negative. We went around once, that's 360, plus 90 more is 450, plus 90 more is 540, plus 10 more is 550. So there we go. All right, hope this makes sense to you. Let me grab a drink here, and we'll continue on. Now, when it says here, let's look at our last topic, coterminal angles. I understand that we've not talked about quadrants yet, but that's pretty much Algebra 1, Algebra 2, pre-algebra, but I'm still going to mention that to you very quickly. In fact, let's go back one page and do it now. Don't forget, in the coordinate plane, this is called quadrant 1, this is called quadrant 2, this is called quadrant 3, and this is called quadrant 4. Okay, so that's all I want to mention about that, and we're going to use that in just a second. But moving on, let's take a look at our last topic, coterminal angles. Go ahead and copy this in your notes, please, as a heading. Your second heading on this video is going to be coterminal angles. I would like you to include the date, please, if you would, so your notes are organized. And here we go. I'm going to go fast, so pause the video when you need to. Two angles are said to be coterminal if they have the same initial side and the same terminal side. Okay, let me say that again. Two angles are said to be coterminal if they have the same initial side and Now, let me give you some examples of what coterminal angles look like, and then I'm going to give you 2 or 3 problems to work out, and then the video will be finished. Okay, go ahead and write a coordinate plane if you would, please. And then I would like you to, let's just draw an angle like this, I guess. Go ahead and draw an angle here that is 45 degrees. So here's my terminal side right here. Or excuse me, my initial side, sorry, and here is my terminal side here, and let's label this 45 degrees. Now, you say, well, Mr. Earhart, what would a coterminal angle be for this angle? Well, let me show you. Remember, a coterminal angle has to have the same initial side and the same terminal side. So if I wanted you to find a positive coterminal angle for 45 degrees, you would have to start at the same initial side, and you couldn't just go to this terminal side and stop. That would be 45 degrees, and I'm asking you to find a coterminal angle for 45 degrees. Well, you would have to rotate around once, that's 360, and then go 45 degrees. So that would be 405 degrees. So 405 degrees would be a positive coterminal angle for 45. Or if you didn't like that, I guess you could have gone around twice. So go around once and then go around again. That's 720, and then 45 more. So 720 plus 45 would be 765. So there's another positive coterminal angle for 45 degrees. Do you see what I'm saying? As long as the angle starts on the initial side and as long as it rotates to the same initial side, then they're coterminal angles. Okay? So some coterminal angles for 45 degrees would be 405 and 765. Now, what if I asked you to find a negative coterminal angle for 45 degrees? Well, remember, a coterminal angle must start on the same initial side, and it has to rotate to the terminal side. So there, I did it. Did I not start on the initial side? Yes, I did. Did I not rotate to the terminal side? Yes, I did. What is the measure of this angle? Well, it's negative 315, right? Because we didn't quite go all the way around. If we would have gone all the way around like this, it would have been 360 degrees. But we stopped 45 degrees short. So 360 minus 45 is 315 degrees. So there is a negative coterminal angle for 45 degrees. Let's find another coterminal angle negative for 45 degrees. Well, let's just go around twice. So we'll start here. We'll go around once. That's 360. And then, sorry about that. Let's see if we can fix this. There we go. Okay, we're going to go around once. That's 360. And then rotate to here. So let's see what we have. Are you ready? We started here. We rotated 360, so there's 360. And then we went almost all the way around again. We stopped 45 short, so that's 315. So we went one complete revolution. That would be 360. And then we went another 315, so 675 degrees, of course negative. That would be a coterminal angle for 45 degrees. And as you can see, there are infinite amounts of coterminal angles. You could start here and go around as many times as you wanted, as long as you added 360 degrees every time. Okay, let's go ahead and try two or three problems and we'll be finished. Okay, I would like you, go ahead and copy this in your notes please, on another coordinate plane if you would. There we go. I would like you to find, and let's call this angle from here to here. Let's call this angle 90, we'll say 35, we'll call this 125 degrees, okay? I want you to find one positive coterminal angle for 125 and then find one negative angle, coterminal angle for 125. Well, let's find the positive angle first, okay? So we have to start on the same initial side. We're going to rotate around once, that's 360, and then 125 degrees more because we have to stop right here. All right, so 360 plus 125, 485 degrees would be a positive coterminal angle for 125. Now, let's find a negative coterminal angle for 125 degrees. So we're going to start right here on the initial side, and let's rotate here. And that's all the further we have to go. Now, if you wanted to go around one revolution and then some more, that's totally fine, but you don't have to. Okay, this is totally sufficient. As long as we have a different number than 125, we're fine. So I've started here on the initial side. I rotated around to the terminal side, and so I did not go a complete revolution. If I would have, that would have been 360 degrees, but I stopped 125 degrees short. So 360 minus 125 is going to be 235 degrees. All right, so negative, of course. So this angle here that starts here and rotates to the terminal side here is negative 235 degrees. So a negative coterminal angle for 125 degrees would be negative 235. All right, let's take a look at one more and then we're finally finished. Okay, let's take a look at one more problem. Okay, I would like you to find a positive and a negative coterminal angle for negative 3 pi over 4. Okay, so the angle would look like this. Don't forget, when we go from here to here, that's a half a pi. Okay, and then from here to here is another half a pi. So if we go from here all the way to here, that's 180 degrees, or that's 1 pi. Now we're going 3/4 of a pi, so we would rotate from here to here, and there's my angle right here, and there's my initial side right there. And so of course this is negative 3 pi over 4. Now, Mr. Earhart, I don't like using radians. Well, just bear with me. Please take some notes on this. We'll do it in radians. Then we'll convert it over to 2 degrees, and we'll do it the same way. All right? Not a big deal. So let's find our positive coterminal angle. Okay, our positive coterminal angle. Well, we're going to start here on the initial side, and we're going to rotate to the terminal side right there. Now, if I would have gone all the way around, that would have been 360, or in other words, 2 pi radians. But I didn't go all the way around. Remember, I stopped 3/4 of the way. So I really went, instead of going 2 pi, I'm 3/4 short. So students, think about that. Come on, wouldn't that be 1 1/4? I mean, if I went from here to here, that's 1 pi, and then a fourth more. That's 1 1/4. And then 3/4 here would give me 2 pi going all the way around. So 1 1/4 is 5/4. So I would say 5 pi over 4. Now if you're confused, you're welcome to first convert this over to degrees and then find your coterminal angle in degrees and then convert it back to radians. It's just longer that way, but you can do that. But I still want to keep trying to introduce you to doing things in radians, okay? So we rotated 1 1/4 pi or 5 pi over 4. So there's one coterminal angle, 5 pi over 4. Now, the rule of thumb is this: if the original problem starts out in radians, then you do want your answers to be in radians. So in a second here, when we convert this over to degrees, that's fine, but we'll have to convert our answers back to radians in the end. Okay, let's go ahead and find a negative coterminal angle, okay? So here we go. Are you ready? We're going to rotate down and around one rotation. That's how many pi? 2 pi. And then we're going to go how much more from here to here? 3/4, right? From here to here is 3/4. So now we have 3/4 of a pi. So we have 2 3/4. Well, 2 3/4, as you know, is the same thing as 11/4 pi or 11 pi over 4. And of course, it would be negative. So the negative coterminal angle for negative 3 pi over 4 would be negative 11 pi over 4. Now, if all of that is confusing, real quick here, I'm going to go really fast. Let's just convert it over to degrees and do it in degrees. I have no problem with that. And then convert your answers back over to radians. That's fine, okay? So here we go. Here's our angle right there. Now, negative 3 pi over 4 would be the same thing as negative 135 degrees. You would multiply it by 180 over pi. Your pi would cancel. 4 would go into this, let's see, 4 45 times, and 3 times 45 is 135. So we have negative 135 degrees. So very quickly, let's find the positive coterminal angle. You would rotate here to here. So you did not make a complete revolution. So you did 360 minus 135, and that's going to be 225. And then if you convert that back over to radians, remember how to convert degrees to radians, you would say 225 times pi over 180. And please trust me, if you took 225 times pi, 225 pi, and 1 times 180 is 180. If you reduce that fraction using your calculator, you would get 5 pi over 4. Okay, so that's fine to do it that way. And then let's find the negative coterminal angle. All right, so the negative coterminal angle would start right here, and we would have again negative 135, and the negative coterminal angle would start here. It would rotate around 360 plus 135 more, so 360 plus 135 would be 495 negative, and then convert that back to radians because your original problem was in radians. So 495 over 1, you should know how to convert degrees to radians. You would multiply it by pi over 180. 495 times pi would be 495 pi. 1 times 180 would be 180 negative. Trust me, if you were to reduce this, you would get 11 pi over 4, okay? Which is the original answer. It would be negative 11 pi over 4, okay? So I hope this video has been a help to you, okay? You need to be able to write angles in standard position and state what quadrant they're in, okay? Quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4, and wherever the terminal side is, that's what quadrant the angle would lie in. So for this standard position angle here, this angle here is considered to lie in quadrant 2 because the terminal side here is in quadrant 2. So make sure you know how to draw terminal angles, angles in standard position, and make sure you know how to tell what quadrant they're in. And it doesn't matter if you were to go around 4 or 5 times, wherever the terminal side is, that's what quadrant the angle is considered to be in. And then also be able to find coterminal angles. All right, that's very, very important. I hope this has made sense to you. If you have any questions, don't hesitate to call or email.